Hello friends, welcome to Expert Guidance. Today in this video we'll be covering the topic A, which is Group 1 Alkali Metals, Lithium, Sodium and Potassium of its Section 2 in Organic Chemistry. Now in this video we'll be looking over the three important elements of Group 1, which are Lithium, Sodium and Potassium. We will see the similarities in the properties of the Group 1 elements, and we'll be also looking over their chemical properties as well. And we'll be also looking over that how we can predict the reactivities of the Group 1 elements depending on their position in the periodic table, and how we can use their electronic configuration to predict their properties. Now I would recommend you to watch this video till the end, because in the end we'll be looking over all the chemical reactions and the balanced equations, which are very important for your exams. So let's begin. When we talk about Group 1, these are all the elements: lithium, sodium, potassium, rubidium, cesium and francium. That is their symbol. You can easily see from the periodic table, and this is their electronic configuration. So lithium is 2,1, 281, 2881. Now you can notice all of them have one electron in their outermost shell. Therefore, they all belong to Group 1. Okay. Now, their reactivity increases down the group because all these elements react by losing an electron, and when you go down the group, the tendency to lose an electron increases. Now, why it increases, we'll just find out. So, if they'll ask you in the exam which is the most reactive Group 1 element, you can easily say cesium and francium. Francium is radioactive, but it is highly reactive. And then, which is the least reactive alkali metal? That is lithium. Out of sodium and potassium, which is more reactive, you can easily say potassium because it is down the group. Down the group, the reactivity of Group 1 metals increases. Okay, now let us look at the physical properties of Group 1. They are highly reactive. Their reactivity increases down the group. Since they have one electron in their outermost shell, they lose one electron and form +1 ions. They are stored in kerosene and oil. Why? Because they are highly reactive. They can easily react with air, oxygen in the air or moisture in the air, and can cause an explosive reaction. They are soft, silvery and shiny, but you must have seen that the metals at times look dull. The reason for that is they react with oxygen in the air, as they're too reactive, and forms a layer of oxides on its surface, and that oxide give them a tarnish appearance. And I've already told you that lithium is less reactive and francium is highly reactive. They have low melting in the boiling points, and the melting in the boiling point decreases down the group. Okay, so I hope these physical properties are clear to you. Now let us look at the chemical properties. Now in the chemical properties, you need to know about three reactions: reactions with water, reactions with oxygen, reaction with halogen. Now always remember, whenever asked in the exam, you'll be writing a balanced chemical equation along with the state symbols. So here I'll be taking an example of lithium, how lithium reacts with water, oxygen, halogen. You can replace lithium with any of the Group 1 element, that is lithium, sodium and potassium, and write the equation the same way. So whenever any metal, that is M, Group 1 metal, that is lithium, sodium and potassium, reacts with water, it forms metal hydroxide. MOH is the formula, plus hydrogen. So if I take M with lithium, lithium with water form LiOH plus hydrogen. Remember, lithium is a solid, water is a liquid, lithium hydroxide is aqueous, and hydrogen is a gas. Now the question can come, what is the observation of this reaction? So you can easily say that we will see that the solid is decreasing in size or mass. And since there is a hydrogen being produced, which is a gas, we'll see the fizzing. Okay, and they can ask you the test for hydrogen. So it's a squeaky pop test. Okay, so metal hydroxide is formed, which is an alkali, and therefore they can ask you what will be the pH. So there'll be an increase in pH. And remember, the reactivity increases down the group. So potassium will react more violently as compared to lithium. When we see the reaction with oxygen, it forms metal oxides, and for the Group 1 oxide, the formula is M2O. So lithium oxide is Li2O, sodium oxide is Na2O. We'll see in bonding how we determine the formulas of the ionic compound, but till then you can just remember that Group 1 oxides will be of the formula M2O. So lithium, which is a solid, reacts with oxygen, which is a gas, and it forms 2Li2O, which is a solid. Okay, and when we react it with halogens, you get the metal halides. Okay, so like lithium with fluorine, remember halogens will be in the form of diatomic molecule, and it gives lithium fluoride, which is a solid. Okay, so these three reactions, very, very important. Make sure you remember them. Make sure you know how to write the equations along with the state symbols, and do not forget to balance the equation. Okay, now as you know, the reactivity with the water will increase down the group. So when you have the reaction with potassium, we will see that there's a fizzing, and there's a very violent fizzing, and the potassium will quickly melt into a ball and catches fire and produces a lilac flame. Whereas sodium will react a little bit intermittently, and all of them, lithium, sodium, potassium, as I told you, alkali metals have less density. We'll see both of them will be floating in water. Okay, all of the three will be producing fizzing because the hydrogen is being released. In lithium, since it is not that reactive, the shape is retained and it quickly, slowly gets smaller. Whereas in sodium, it melts into a ball while reacting. So it will get deformed earlier than lithium. And potassium, it quickly melts into a ball, catches fire, and produces a lilac flame. This observation can also tell you that the one that is reacting very explosively is one of the elements which is down the group. Okay, so I hope the physical properties, the chemical properties, and what is the electronic configuration of group 1 is clear to you. Now comes a very important question. Why the reactivity of group 1 increases down the group? Okay, now, in order to explain that, you need to remember that if any question comes in, you need to first explain that alkali metals, they react by losing electron, and the tendency to lose the electron increases down the group, therefore they become more reactive. Now the question is, why it increases down the group? Now, the tendency to lose an electron depends on these three factors, and all these three factors contributes to an increase in tendency of the alkali metals to lose an electron down a group. First is the nuclear charge. Now, if the nuclear charge will be smaller, the outer electron will be weakly held by the nucleus and can be lost easily. So once we go down the group, you have seen, if you see the electronic configuration of the group 1 elements, can you see that the shells are increasing? So there are more electrons that are being added. So the atom is getting bigger in size. As the atom is getting bigger in size, the outer electron is getting further away from the nucleus. So as the outer electron is getting further away from the nucleus, the nuclear charge decreases. The inner electrons, they are shielding the outer electron from whatever nuclear charge that is present, and bigger the size of the atom is also decreasing the nuclear charge. So due to all these factors, down the group, the tendency to lose an electron increases, and alkali metals react by losing an electron. Therefore, the reactivity of group 1 increases down the group. Okay. Now remember, when you get this question, you need to talk about these scientific terms, the nuclear charge, shielding, and size of the atom. Okay, so I'll summarize. Down the group, the atom size increases due to increase in the number of electronic shell. This results in the outer electron being further away from the nucleus. As the outer electrons become further away from the nucleus, the nuclear charge decreases. Increase in number of shells also increases the shielding and shields the outer electrons from the nuclear charge. Therefore, the tendency of an atom to lose an electron increases down the group, resulting in increase in reactivity down the group. Okay, so remember, in group 1 you need to know the reason why it increases, the reactivity increases down the group, and I hope now you're able to answer that. Okay, I hope this chapter is well clear to you. Now what is the next step? Check the specification, make sure everything which is there in the specification is crystal clear to you, and do the exam questions on this chapter. The exam questions on this chapter can be found on my website. The link is mentioned in the description box below. I hope you liked the video. If you like the video, then do please comment on this, do like, and also click the bell icon so that you will come to know the upcoming videos, and you will get a quick notification of the videos that I'll be uploading. If there's any if you've really found this video helpful and want me to make more videos on the topic of your choice, then leave a comment below with the topics you want, and I'll make sure and I'll try my level best to put that up before your exams. Okay, now Do go over the chapters, and if there's anything that you still do not understand, leave a comment below or come to my website. There's a 24/7 chat support. I'm available all the time during your exam time to answer all your queries. Okay, so I'll see you next in the next video where we'll be covering the next chapter, and I look forward to your comments on how you find this video and what's the next video you want. Till then, happy revising.